Hello everyone. In this video we are going to learn how to write down thermochemical equations for the formation of ionic solution using Hess's law. So there is a lot of information that we are going to learn in this video. First of all, we will come to know what is a thermochemical equation, then how to write down a thermochemical equation, then how many different enthalpy changes are involved during the formation of an ionic solution, and ultimately in the conclusion we will apply Hess's law to write down the formula for doing calculations related to the formation of ionic solution. Okay, the type example that I have chosen, it is the lithium chloride solution. Now what you must remember, one thing, what is the thermochemical equation? Thermochemical equation is a balanced chemical equation that also includes enthalpy change for that reaction. Any chemical equation that includes enthalpy change of that reaction is known as thermochemical equation. Second thing you must remember, whenever we write down thermochemical equations for the formation of ionic solution, there are three types of enthalpy changes which are involved. There are always three types. What are the three types for the formation of ionic solution? Three types of enthalpy changes. Number one, obviously, enthalpy change of solution. That enthalpy change that is always involved, it is number one, enthalpy change of solution. Number two, lattice enthalpy, if we are using some ionic compound, and if we are using some covalent compound, then we will use bond enthalpy. And number three, hydration enthalpy. So there are three types of enthalpy changes that we use while writing thermochemical equations for the formation of ionic solution. Number one, enthalpy change of solution. Number two, hydration enthalpy. Number three, lattice enthalpy if ionic compound, and bond enthalpy if covalent compound. Let's start writing thermochemical equations for lithium chloride solution. One more thing, remember, we can write down thermochemical equations for the solution formation in two different styles. So we are going to discuss both these styles in this lecture. First of all, according to the first style, what you must remember, how to write down thermochemical equations. Okay, let's suppose we take lithium chloride. Lithium chloride is solid, and this lithium chloride, if we add it in water as a solvent, it is written and spoken as aqua. What will happen when lithium chloride, it dissolves in water, lithium chloride solid, it will be converted into hydrated lithium and chloride ion. Hydrated mean both the ions, they will have which physical state? They will be present in aqueous physical state. So whenever this happens, we can say that solution formation has taken place. Now what is the enthalpy change of this reaction? When some substance from its stable physical state, solid, liquid or gas, it dissolves in water and becomes hydrated, this enthalpy change is known as standard enthalpy change of solution. Now what you should remember, this chemical equation including enthalpy change, whether we have used the label only or we insert the numerical value, this chemical equation is known as thermochemical equation. Okay, now we have introduced one type of enthalpy change, that is enthalpy change of solution. Now we are going to introduce the other two types of enthalpy changes. Look, if we provide energy and we break lithium chloride solid into gaseous lithium and chloride ions, we have broken the ionic bond. So that is why what this enthalpy change will be known as, this enthalpy change when an ionic bond is broken, it is known as lattice enthalpy, and this lattice enthalpy would be positive because it is involved in bond breaking. Bond breaking is always endothermic. So we have introduced the lattice enthalpy. If instead of ionic compound, if ever you have been given some covalent compound, instead of lattice enthalpy for bond breaking, you will use which enthalpy change? You will use bond enthalpy. Now the compound has been broken down, gaseous ions, they are ready to be surrounded, to be attracted by water molecules. Whenever gaseous ions are surrounded and attracted by water molecules, that process is known as hydration. That process is known as hydration, and that enthalpy change is known as hydration enthalpy change. Now the gaseous ion will become hydrated ion, and on the reaction arrow you can introduce hydration enthalpy for the lithium ion multiplied by 1 because there is 1 mole of lithium ion, and hydration enthalpy of chloride ion multiplied by 1 again because there is 1 mole of chloride ion. Now this is one complete style for writing thermochemical equation for the formation of ionic solution using Hess's law. You can see we have written thermochemical equations involving three types of enthalpy changes: enthalpy change of solution, lattice enthalpy, hydration enthalpy. I have told you if the compound will be covalent, instead of lattice enthalpy you will have to introduce bond enthalpy. Okay. Now let's start writing thermochemical equation for the same ionic solution using second way. Now in the second way, again from where you will start, simply you will take the compound, you will add it in water, the compound would dissolve in water. After dissolution the compound will go into hydrated ions, and this step will be known as solution formation, and the enthalpy change for this step will be enthalpy change of solution. So no difference in this case. Where is the difference? The difference is in the previous style, in case A, we have shown bond breaking when the solid ionic lattice has been converted into gaseous ions. But what you can do, you can reverse that arrow, because instead of bond breaking you can also show bond formation. If you want to show bond formation, what you will have to do, you will have to reverse the direction of the arrow from the gaseous lithium and chloride ions towards the solid ionic lattice. The enthalpy change for this step will be lattice enthalpy, but now when you will insert the numerical value of this lattice enthalpy, you will insert negative sign. Why? Because in this case bond formation is taking place, and bond formation is always exothermic. So this is the difference, this bond breaking or bond formation, you can reverse this arrow. Otherwise when these gaseous ions are present, when they will be surrounded and attracted by water molecules, hydration process will take place and hydration enthalpy, no difference. So two enthalpy changes, you cannot change their direction, only one enthalpy change. Enthalpy change, which one? Lattice enthalpy, or if covalent compound is given, bond enthalpy. You can reverse only the green arrow. So depending on the position, depending on the direction of the green arrow, you can insert the numerical value, you can adjust the numerical value accordingly. Either you can write it down positive enthalpy change if it is bond breaking, and negative enthalpy change if it is bond formation. So this is the difference in these two styles whenever you want to write down thermochemical equations for the formation of ionic solution. Both these styles are equally acceptable. You can write down any one of these, you can adopt any one of these two styles, no problem. But what next you should remember, let's apply Hess's law for each of these two styles, and what difference you will notice if we apply Hess's law in style A. What you will have to do, you will have to identify what is the initial stage and what is the final stage. How to identify initial stage? Initial stage is the one where both the arrows they take a start, from where both the arrows they take a start, they touch their tails, that is the initial stage. And final stage is the one where both the arrows they touch their heads, where they end up. So if you just apply this idea, you can come to know that lithium chloride solid and aqua, this is the initial stage, because you can see two arrows they are taking a start from this position. And what will be the final stage? The final stage will be the hydrated lithium and chloride ion, because two arrows are ending up at this position. Now what you should remember in style A, when you have identified initial and final stage, what will be the resultant vector? The resultant arrow, the resultant vector is the single arrow that is the sum of the other two. In case A, always the resultant vector will be the enthalpy change of solution. The resultant vector will always be the enthalpy change of solution, and it would be equal to sum of lattice enthalpy and hydration enthalpy of lithium ion and hydration enthalpy of chloride ion. So important thing to be remembered, if you are showing bond breaking during the formation of ionic solution, if you are showing bond breaking, the resultant vector, the enthalpy change of the direct path will be enthalpy change of solution. And if you are showing bond formation during the formation of ionic solution, then which enthalpy change will be the resultant arrow? C. In style B, the initial stage gaseous lithium and chloride ion, and the hydrated lithium and chloride ion final stage. Now what will be the resultant vector in this case? That is equal to the sum. In this case, if you are showing bond formation, the resultant vector will always be hydration enthalpy. Hydration enthalpy of the positive ion plus hydration enthalpy of the negative ion, it would be equal to lattice enthalpy plus solution enthalpy. So try to understand the difference. You can write on thermochemical equation using any one of these two styles for the formation of ionic solution. But what you must remember the final formula for Hess's law. It would be different. But when you will insert the numerical values to do some calculation, you will get the same answer. Mathematically, you will get same answer. So there is nothing to worry about. I hope you would have enjoyed this lecture. Thank you for your time. Bye for now.